Please just bear with me. I am back. Okay, I'm very sorry for coming late. Is that clear? You're all welcome. Sorry for coming late. Please just bear with me. The network here is not friendly. Yeah, so I have to use alternative. Okay, you're all welcome. Today will be very brief. I think we are left with 30 minutes if I'm not mistaken. We are going to consider differential equations. The definition, a differential equation is an equation that involves a function, says y, of one variable, say x, and derivatives of y, or differential of x, comma what, y. Example, look at the example. You can see differential equation of this one. dy is equals to x plus 2y dx, or this is the same thing, dy all over dx equals to x plus 2y. Then 2, example 2, d square y all over dx square plus 2 dy all over dx plus 3y minus 7 sine x plus 4 equals to 0. Are you following? Do you understand? Okay. So, I'm very sorry about this thing. Okay. It means we are going to complete our 1 hour. Is that clear? So please bear with me. The class supposed to end 8 to 9, but we will stop 9:30. Please just bear with me. Thank you for your cooperation. Okay. So now, don't be surprised that as you can see, this is a differential equation of order what? First order, right? Our dy all over the x is the same thing as y prime, or this is the same thing as y dot. In physics, this is what they use. So please take note, if you come across y prime or y dot, is the same thing as the differential equation, that is first order differential equation. That is, if we have this is first order. Then if we have d square y all over the x square, this is y prime prime or y dot dot. It means this is a second order, amen? Second order. Then if you have d cubed y all over the s cubed, this is equals to y prime 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 or y dot dot dot. This is equals to third order. Is that clear? So how to identify the orders of a differential equation? So do you agree with me? Please try and inform others to be part of the class. I'm saying only, is it 9 or 10 people here? Try and invite them that the class has commenced. Is that clear? Okay. Like, comment, and share. It's very important. Okay. So that is that. So these are examples of what? A differential equation. So let us know the order of this differential equation. The order of this differential equation, the order of this differential equation is first order. This is first order. Then let's look at the second one. The order of this differential equation is what? What is the highest order? We have d square y over dx square. We also have dy over dx square. So the highest order here is what? 2. So this second example, the order of this differential equation is the second order differential equation. Do you understand? Are you following? Are you following? And you can see the board clearly, right? Okay. So let's proceed. Is that clear? So as I was saying, that is a differential equation. So this is how to identify the order. So okay, let us assume, let's look at it. Yeah. If assuming we have d cube y all over the x cube plus 2d square y all over the x square plus dy all over the x plus 3 equals to 0. What do you think is the order of this differential equation? Just look at the board very well. The order of this differential equation is, as you can see now, we have d cube y all over the x cube plus 2d square y all over the x square plus dy all over the x plus 3y equals to 0. So the highest order here is what? 3. So the order of this differential equation is what? 3. Do you understand? So this is how to okay. So that is that. Is that clear? So you can now know how to identify the order of a differential equation. Is that clear? So that is that. Then let's consider the degree of a differential equation. Degree of differential equation. Degree. How can we identify the degree? Is that clear? So let's have a differential equation. If we have dy all over dx, this is equals to 2x plus y. When we say the degree is just talking about the power of a differential equation. You can now see that the power here is what? 1, true or false? So the degree of this differential equation is 1. Then assuming we have d square y all over the x square plus 2x dy all over the x all in brackets raised to power 2 plus y equals to 0. If you are asked to find identify the degree of this differential equation, it's simple as ABC. Here, if you want to consider the order of this differential equation, the order is what? Second order. Why? Because the highest order here is d square y all over the x square, y here dy all over the x, true or false? So it's second order differential equation. But if now we want to consider the degree of this differential equation, let us have it in this form. So you can now see that the power here is 1, and the power here of this first order here is 2. So this is the highest degree. So the degree of this differential equation is 2. And the order is order 2, second order. Do you understand? Are you following? Are you following? Okay. So if you are following, let's move further to consider some examples of a differential equation. Okay. Example. So let's solve some differential equations. Coming. Okay. Okay, yeah. Show that example show that a y equals to 2 exponential x and b y equals to 3 are solutions of the differential equation of the differential equation y prime prime of 1 minus x then plus y prime x minus y equals to 0. Yeah, we want to look at this very question. The class is very few. I can see only 14 persons here. It seems some of you are just playing. So we want to look at this example. It's simple as ABC. So let's look at it together. Okay. Yeah. At first, we write solution. They said we should show that y equals to 2 exponential x and b y equals to 3x are solution of the differential equation. This is a differential equation that is y prime prime open bracket 1 minus x plus y prime x minus y equals to 0, right? You know, I told you that y prime prime is the same thing as d square y all over the x square, two of us. So by the time you by the time we can still transform this equation in this form, and y prime is also the y all over the x. So it means this is the same thing as d square y all over the x square open bracket 1 minus x plus dy all over dx, that is, this is x minus y equals to 0. So one can transform this equation in this one. They are all the same thing. It's for the same purpose. It will serve the same purpose. Take note. Are you following? Is that clear? So now we either use this or this. I'm just trying to tell you how this and this are the same. Is that clear? So now they said we should prove that this is a solution of this differential equation. And this differential equation is called what? What is the name of this differential equation? I'll give you 1 mark. Tell me the name of the differential equation. What is the name of the differential equation? Yes? What is the name? The differential equation. 1 mark. The first 2 persons. 1 mark. Look at the board. I give you only 2 minutes. Nobody? I'll give you 1 mark. I will give you 1 mark. The name of the differential equation. No. What is there? Look at it. What is there? Second order now. Second order DE. Differential equation. Because I said y prime prime means second order. Then y prime means first order. Okay, nobody got it. So let's proceed. It's okay. That is that. So now they said we should show that. So let's consider A. A, y is equals to 2 exponential what? X. Right? Okay. So let's look at it together. So it means we should show that this is a solution to this second order differential equation. How? It means we are going to differentiate this function twice and substitute into this second order differential equation so that it will show that both the left hand side and the right hand side must be what? 0. Is that clear? So if this is 0, this is 0, it means this is a solution to this differential equation. Are you following? Do you understand? So let's consider. So let us differentiate. If we differentiate 2 exponential x, it means our y prime will be what? Still the same thing as 2 exponential x. True or false? Then since it is a second order differential equation, you have to differentiate it again. If you differentiate it again, y prime will still give you, differentiate this, it will still give you the same thing, 2 exponential x. True or false? How to differentiate exponential function? Look at it. You just hold this one. You have 2 exponential x. Hold this one constant. Differentiate what is there. Just assume that you have x here. So we have done exponential functions. So if you differentiate x, is it not 1? Use this 1 to multiply what is here. 1 times 2, then times the function is the same 2 exponential x. True or false? True or false? Look at the board. Very well. True or false? It's true, right? Okay. So let's proceed. Let us proceed. So let us prove to show whether this function will be a solution to this differential equation. So this means that our y prime is equals to 2 exponential x, y prime is equals to 2 exponential what? X, isn't it? So it means anywhere we see y prime, we write 2 exponential x. Then anywhere we see y prime in the differential equation, we write 2 exponential x. So here we have what? y prime prime, and y prime prime is 2 exponential x. So we write 2 exponential x, open bracket 1 minus x, then plus y prime is, we have x here, right? So x times this, we are going to have 2x exponential x, then minus, what is your y prime? Your y prime here is 2 exponential x. So write 2 exponential x equals to 0. So let us multiply out. Do you understand up to this point? Please look at the board. If there is any question, please ask. If there is any question, ask. If there is any question, ask. If there is no question, we proceed. The number here is very few. That is to show that you people are not serious. Number here is very few. Okay. The second step. Abdurrahman, you said you don't understand the second step. Okay. Yeah, Abdurrahman, is it the y prime prime you are talking about? Is it this one or this one? This one, okay. Let me take it all over again. When you have y equals to 2 exponential x. Okay, let us assume that you are asked to differentiate y equals to exponential x. If you are to differentiate exponential x, your y prime, is it not the same thing as exponential x? It's the same thing, true or false? Then y prime prime, you differentiate this, is the same thing as exponential what? X. So now, is it because they said y equals to 2 exponential? Yeah, this is a constant. Just assume that this is your a. So if you differentiate, you will use it to multiply it again and again. So it means that y prime will now be equals to, you know, I told you that this is x. So if you differentiate x, it's going to give you 1. You need to multiply whatever that is here, which is 2. So it's going to be what? 2 multiply by the function 2 exponential x. So you have 2 exponential x, then y prime prime. The reason why the y prime prime is because the differential equation is a second order differential equation. So you have to differentiate this function again to obtain your y prime prime. Amen? Then the same thing, if you differentiate this function, it still gives you back the same answer. 2 exponential x. True or false? Now, you now come to the differential equation. Look at it here. We have y prime prime. We have y prime. We also have y. So we substitute into this differential equation. What is your y prime prime? It's 2 exponential x. Look at it here. Look at it here. Instead of y prime prime, we write 2 exponential x. Open bracket. Look at it. 1 minus x plus, what is your y prime? Y prime is 2 exponential x. Then here we have x. So use it to multiply the x here. So it's going to give you 2x exponential x minus, here we have y. What is your y? Your y is the function 2 exponential x. Then you substitute it. Instead of this y, you write 2 exponential x equals to 0. Do you understand, Abdurrahman? Abdurrahman, are you following? Abdurrahman, do you understand? Okay, so you mean we can proceed, right? It's okay. It's okay. So let's proceed. So now what left is for us to satisfy that this function is a solution to this second order differential equation. So we have to multiply out the bracket. 2 exponential x times 1 is the same thing as 2 exponential x. Then 2 exponential x minus x. We are going to have minus 2x exponential x, then plus 2x exponential x minus 2 exponential x equals to 0. Look at the board very well. If you can see what I am saying, you don't need the prophet to tell you. This and this will cancel. True or false? This and this will cancel. You can now see that 0 is equals to 0. So we conclude that this is a solution to this second order differential equation. You can now see that 0 is equals to 0. But assuming the left hand side, maybe all of a sudden you got exponential x equals to 0. It means this can never be a solution to this differential equation. Why? Because the left hand side is not equals to what? The right hand side. Take note. So any question before we move further to consider the B part of the question? Any question, please ask. If you have any question, ask. Do you have any question? Abdurrahman, any question? Yeah, that is the final answer. That is the final answer. So it means you can do the B part. Just differentiate it twice, B. Then substitute it into the differential equation. Is that clear? The same step, yeah, the same method. If you know how to differentiate, yeah, that is the final answer. If you know how to differentiate, I don't think B will be a problem to you. Okay, so let's consider the B part. I can claim this, right? The B part is B. Y equals to 3x. So let's differentiate and substitute. If we differentiate 3x, what are you supposed to have? You are going to have what? 3. True or false? Then differentiate y prime to give us y prime prime. We differentiate 3. Is it not 0? Yeah, it's 0. So anywhere you see y prime prime, you write 0. Anywhere you see y prime, you write this. So it means, okay, classwork, the first set of students, the first 5, I give you 3 minutes to do that. Substitute it and show what you know. Snap and drop it in the comment section or type it how it will look like. Substitute it. I give you 3 minutes to do that. 2 marks. I'm waiting for you. 2 marks. 3 minutes. Your time start counts now. Yeah, who has finished? Nobody? You cannot substitute that into the guy. Nobody. I need show working. Are you sure? Okay. So let's substitute in. Y prime is 0. We put it here. So here instead of y prime, we write 0 times 1 minus x. This is what I asked you to do, but so unfortunate that you don't understand what is going on here. So here y prime is 3, then here is x, 3x minus y prime. Y is what? 3, right? Sorry, 3x. Y is 3x equals to 0. True or false? 0 times this, here will be 0 plus 3x minus 3x equals to 0. This cancel. 0 equals to 0. So this is also a solution to this second order differential equation. So unfortunately that people cannot substitute this and this into this equation to obtain 0 equals to 0. Why? Huh? Why? I said show working. Emmanuel, it did not show working. Show working. The class is very few and okay, let's proceed further to consider my examples. Okay. Let us proceed further to consider my examples. Okay, here we have some questions here. We have some questions here. Okay, let's consider some. If y equals to, another example, if y equals to 4 exponential 4x times cos 3x, and it says show, amen, show that our d square y all over the x square minus 8 dy all over the x plus 25y equals to 0. Yeah, it's a very good question that we are going to have to look at. So let's proceed further. Let us proceed further. Okay, yeah. So what do? We write solution. Y is equals to exponential 4x cos 3x. So as it is now, you study the nature of the differential equation. Look at it here. This differential equation could be written in this form, or y prime prime minus 8y prime plus 25y equals to 0. This is the same thing as this. So if you can see what I am saying now, what we need to do, what are we going to do? we have to differentiate this function. What is the nature or the order of the differential equation? The order of the differential equation is a second order differential equation. True or false? Why? Because we have y prime prime. True or false? So it means we are going to differentiate this function how many times? Twice, and substitute into either this or this differential equation. That is what we are going to do. Amen? That is what we will do. Is that clear? Are you following? Okay. So, please, our class will end 9:30. So take note. So if you agree with me, let us differentiate this. Y prime, this is, we use product rule. True or false? We hold this one, differentiate this one. So if we differentiate exponential 4x, hold this one constant, cos 3x. We are supposed to have 4 exponential 4x. Use it to multiply cos 3x, so it means we are going to have cos 3x. So here you are going to have 4 exponential 4x cos 3x, then plus whole exponential 4x constant, then differentiate cos 3x. If you differentiate cos 3x, what are you supposed to have? You are supposed to have 3 minus 3 sine 3x. So if you use this minus to multiply this plus, you are supposed to have minus, then use it to multiply this minus 3 exponential 4x sine 3x. Amen? Okay? Then, since it is a second order differential equation, we still have to differentiate this function. This, so y prime prime will now be, here we'll still use product rule. Here will give us 16 exponential 4x cos 3x. Then differentiate this, we are going to use to multiply, we are going to have minus 3 sine 3x. Then we use it to multiply this. There will be 12 exponential 4x sine 3x. Then differentiate this. Product rule is applicable. Whole sine 3x constant minus 12 exponential 4x sine 3x, then whole minus 3 exponential 4x constant, then differentiate sine 3x, you are going to have minus 9 exponential 4x cos 3x. Yeah, this is what you are supposed to have. 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 If you know your product rule very well, this is what you are supposed to have. Okay? Okay, so it means we have to substitute this and this into this differential, second order differential equation. So our y prime prime is this. Let's write it down. 16 exponential 4x cos 3x minus 12 exponential 4x sine 3x minus 12 exponential 4x sine 3x minus 9 exponential 4x cos 3x. Then what we have here, we have minus 8y prime. What is our y prime? So it means we need to use this 8 to multiply minus 8 times 4 is 32, right? Yeah, 32 exponential 4x cos 3x. Then use 8 to multiply this is minus 24, right? Minus 24 exponential 4x sine 3x. Then what we have here, plus 25. Our y here is exponential 4x cos 3x. So use it to multiply this. So here will be 25 exponential 4x cos 3x equals to 0. So we don't know whether this one will be a solution to this problem. So let's look at it together. This and this, they are the same. Then this and this and this, they are the same. So if we collect like terms, here we are going to have already, we can, here will be this one minus this. Here we have 16 exponential 4x. Amen. Then cos 3x. Then if we add this, we are going to have minus 41 exponential 4x cos 3x. Yeah, then plus what? Plus 25 exponential 4x cos 3x. Then we can add this to give us minus 24, right? Minus 24 exponential 4x sine 3x. Then here is minus 24 exponential 4x sine 3x equals to 0. Yeah. This is what you are supposed to have. Then, if you can see what I am saying, look at the board very well. It's not difficult. Look at the board very well. It is not difficult. Okay. Yeah, look at the board very well. So, far so good. This minus this, you are supposed to have minus 48, right? Minus 48, right? Then come down to add this. What are you supposed to have? This is 25. So minus 25 of 41 minus 41 plus 25. What are you supposed to have? Huh? What are you supposed to have? Look at it. Huh? Okay, let's look at it this way. Here we are going to have wait, yeah, something is wrong somewhere. Yes, here is supposed to be, this is -8, right? So -8 times this, where is it? Yeah, -8 times this, 32, right? Then minus this times, so here is supposed to be plus. Here is supposed to be plus. And here is plus 24. Yeah, supposed to be plus. Supposed to be plus. So as you can see now, here we are going to have this and this will cancel. This and this will cancel. Then here will give you 25. Here will give you 25. Minus 25 minus 25 exponential 4x cos 3x plus 25 exponential 4x cos 3x equals to 0. So you can now see that 0 is equals to what? 0. Amen? So this is a solution to this differential equation. I will give you assignment to. I will give you guys assignments. So if you like, you do it. It's none of my business, and it will be part of okay, so that's the answer. Let's move further. I'll give you assignment. Let us move further to consider to find the general solution of a second order differential equation. Is that clear? Let's move further to find the general solution of a second order differential equation. Is that clear? Okay, yeah. Let us just assume that we have a differential equation of this form. Our d square y all over the x square plus 2 dy all over the x plus 4y equals to 0. Amen? So if we want to find the general solution of this second order differential equation, we might set y equals to exponential either mx. Then the general solution will now be if the roots are distinct. 1. If the roots are distinct roots, that is m1 maybe equals to, let's just assume a figure, m1 equals to 1 and m2 equals to 2. It means the general solution, therefore the general solution, take note of this, the general solution will now be y equals to either a exponential m1x plus b exponential m2x. But sometimes in some textbooks they use y equals to c1 exponential m1x plus C2 exponential m2x. You don't have a problem. Either you use this one or use this one. They are all the same thing. Is that clear? But if the roots are the same, it means it means m1 equals to m2. Maybe assume that 1. You can now see that m1 2 is 1. That is m1 is 1 and m2 is 1. That is the meaning. So it means the general solution. Therefore, the general solution will now be y equals to a exponential m1x plus bx exponential m2x. So in some textbooks you may see it in this form: c1 exponential m1x plus c2 exponential here will be x, c2x exponential m2x, right? Do you understand? So sometimes you may see it in this form, or this is the same thing as y is equals to c1x exponential m1x, the general solution, exponential what? m2x. Take note. So it's the same thing, it's just the same meaning. Is that clear? Take note. So take note of all these things I am doing now, because it will be part of your exam. It's okay. So let's move further to solve one problem. Then I will drop this thing. Amen. Okay, let's consider one example here. From here, one example here. Okay. Example. Solve the differential equation. Solve d square y all over dx square plus 3 dy all over dx minus 4y equals to 0, right? Okay, so let's look at it together. We write solution, right? Our d square y all over dx square plus 3 dy all over dx minus 4y equals to 0. So how can we solve this differential equation? Is the solution to this differential equation is we must say let y be equals to either a exponential mx or anyone. So we have to differentiate this function. Amen. Let's differentiate this function. So if we differentiate this function twice, it means our y prime will now be equals to am exponential mx, and y prime is equals to am square exponential ms square. So we substitute this into this formula, this differential equation. Anywhere you see y prime, write this, y prime, you write this. Is that clear? So let's substitute. Here would be a m squared exponential mx plus 3. What do you have here? A m exponential mx. Then minus, what is your y? Y is a exponential mx, which is equals to 0, right? So what is common in this equation? Our a exponential mx is common, so we factor it out. So it means we are going to have a exponential mx, open bracket, m squared plus 3m minus, oh, here is 4. Here is supposed to be 4. Yeah, minus 4 equals to 0. So if this and this can never be equals to 0, mx cannot be 0, it means this is m squared plus 3m minus 4 is equals to 0. So it means we call this auxiliary equation. Auxiliary equation. This is a quadratic equation, quadratic form. The reason why it is called an auxiliary equation is because it was extracted from a differential equation, true or false. So this is called an auxiliary equation, no more quadratic equation. But it's the same way we are going to, the way you are going to solve a quadratic equation, that same way you are going to solve this auxiliary equation to obtain your x1 and y1. That is, we said to solve the differential equation to find the general solution or obtain the general solution. The general solution. Okay? So let us solve it. Either we use formula method or factorization method. So if we are to use factorization method, what can we do? I think minus 3 and minus what? 1, isn't it? So here would be m squared minus 3m minus m minus 4 equals to 0. So if you can see what I am saying, our m squared minus 3m minus open bracket minus 4. M minus 4, what is common? M, right? So here will be m minus 3 minus 1 open bracket m plus 4, right? Plus 4 equals to 0. By the time you use this to multiply out, you obtain your what? So here we are going to have listen, here we are going to have our m1. Oh, no. Sorry. Here supposed to be minus 4m plus m minus 4, right? Okay? Yeah. So if you can see what I am saying here, here supposed to be m open bracket m minus 4, then plus 1 open bracket m minus 4 equals to 0. So as you can see now, here will now be m plus 1 equals to 0, then m minus 4 is equals to 0. So it implies that our m1 is equals to minus 1 and m2 is equals to plus 4, right? Plus 4, right? Am I right? Yeah. So now the general solution will now be that y equals to c1 exponential m1x plus c2 exponential m2x. So our general solution will now be equals to our c1 exponential, what is our m1 minus x plus c2 exponential m2 is what? Is 4x. So this is the general solution. Am I right? This is the general solution. So any question? We are going to stop here, but I will drop assignment now. I will drop assignment now. I will drop assignment now. Oh, we made a mistake there. Sorry. There's a mistake there. There's a mistake here. We are looking at, here supposed to be, sorry, there's a mistake here. Please. Yes, supposed to be plus 4. Y here supposed to be minus 1. So that we'll still get back this. Please, let's take it all over again. Please, there's a mistake here. So here supposed to be m, open bracket, m plus 4, then minus 1, open bracket, m minus, plus 4 equals to 0. There's a mistake. This is how it's supposed to be. So our m minus 1 equals to 0, then m plus 4 equals to 0. So our m1 equals to plus 1, and m2 equals to minus 4. That is mathematics for you. Please, nobody above mistakes in mathematics. So here is supposed to be plus x, then here is supposed to be minus 4x. So take note. So it means our general solution, y is equals to c1 exponential x plus c2 exponential minus 4x. This is our general solution. Thank you very much. And let me drop the assignment. Is that clear? So this is how you are going to do it. Okay, let me clean this up and drop the assignment. It's very important. Okay, assignments. Assignments. Take it very serious. Otherwise, you are on your own. Assignment. 1. One. Show that obtain the general solution. The general solution of obtain the general solution of d square y all over the x square plus 3dy all over the x equals to 0. That is 1. Then the second one is 2. If y equals to exponential x times x, show that our y prime is equals to y prime minus 2 open brackets 1 plus tan x close bracket y prime, then plus open bracket 1 minus 2 tan x close bracket y equals to 0. I think these two questions are enough for you. Let me go through it again. So they say obtain the general solution of this differential equation. This is a second order differential equation. Then another one, if y equals to this, show that this is equals to this. Okay, so we are going to stop here. Thank you for your time. I love you guys. Have a wonderful weekend. Thank you and God bless you. Please don't forget to share, like. I wish you all the best. Thank you. Love you all. Bye.